In this video, we'll discuss the 3 different pumping methods used in central plants for the distribution of chilled water. This includes primary variable flow, primary secondary with distributed pumping, and primary secondary variable flow with tertiary pumping. There are many other pumping configurations, but in this video, we'll cover the first 3. Primary variable flow. In a primary only variable flow chilled water system, the operation is centered around using only primary pumps to circulate chilled water through the entire system. The key feature of this system is the variation of flow rates in response to the cooling load, providing a more energy efficient operation. Here's an overview of how the primary only variable flow chilled water system pumping arrangement typically works. Chillers. Chilled water is generated by one or more chillers in the system. There is a chilled water temperature sensor in the chilled water supply pipe leaving the chiller. The chiller cools the water to the desired chilled water supply temperature before it is sent to the cooling coils. The 3-way valve ensures that the chiller receives the minimum flow required by the chiller manufacturer. The 3-way valve bypasses the coil when the demand for cooling is reduced at this coil. This provides the chiller with a minimum amount of flow. There are better ways to do this that we'll cover in another video. The chilled water is then distributed to the various cooling loads such as air handling units, AHUs, fan coil units, FCUs, or other cooling devices in the building. The chilled water is distributed using variable speed pumps. Primary chilled water pumps. The system relies on one or more primary chilled water pumps to circulate water through the chillers and the entire distribution system. These pumps are typically equipped with variable frequency drives, VFDs, to adjust the pump speed and flow rates based on the demand. VFDs on the primary pumps allow for the adjustment of the pump speed to match the varying cooling load. Lower pump speeds during periods of lower demand contribute to energy savings. The demand is determined by a differential pressure sensor installed at a remote location. Differential pressure sensor. The cooling coils have supply air temperature sensors that control the amount of chilled water flowing through the 2-way control valves. As demand in the space reduces, the 2-way valves modulate toward the closed position, which increases pressure in the chilled water system. This increase in pressure is sensed by the differential pressure sensor and is communicated to the VFD. The VFD then slows down the speed of the pump, which reduces the amount of chilled water circulated throughout the system. Energy efficiency. The system's energy efficiency is enhanced by avoiding the need for secondary pumps and the associated energy consumption in a primary secondary system. The variable flow nature ensures that the system operates at optimal conditions, minimizing energy wastage. Primary secondary with distributed pumping. In a primary secondary variable flow chilled water system with a distributed pumping arrangement, the operation involves 2 separate loops, a primary loop and a secondary loop. The design is often employed in larger and more complex chilled water systems, including when there are more than one building involved. Here's an overview of how the system typically operates. Primary chilled water pumps. One or more primary pumps circulate chilled water through the chillers and the primary loop. In this design, there is a pump dedicated for each chiller. A common leg connects the primary and secondary loops. Secondary chilled water pumps. The secondary pumps are moved out of the central plant and into the buildings, bringing them closer to the cooling coils. These pumps provide the capacity and the system pressure to bring the water from the common leg through their most remote coil and back to the common leg. These pumps will also operate using VFDs to match the load of the coils they serve. Energy efficiency. The primary-secondary design allows for more precise control over the distribution of chilled water to the loads. This avoids over-pressurizing the secondary loop, which can occur when the secondary pumps are located within the central plant. By separating the loops, the system can adapt to changes in the secondary loop without affecting the primary loop, contributing to overall energy efficiency. Distributed pumping offers redundancy and flexibility, allowing for continued operation even if one secondary pump is offline for maintenance or repair. This primary-secondary variable flow chilled water system with a distributed pumping arrangement is a robust solution for larger commercial buildings where precise control, energy efficiency, and redundancy are critical considerations. Primary-secondary variable flow with tertiary pumping. In a primary-secondary variable flow chilled water system with tertiary pumping, the operation involves three separate loops: a primary loop, a secondary loop, and a tertiary loop. This design is employed in large and complex chilled water systems to optimize control, enhance energy efficiency, and provide additional flexibility. The primary and secondary pumps can be located in the central plant, while the tertiary pumps will be located in the individual buildings where the cooling coils are located. Here's an overview of how the system typically operates. Chilled water pumps. One or more primary pumps circulate chilled water through the chillers and the primary loop. Separate pumps circulate chilled water through the secondary loop. The secondary pumps respond to fluctuations in the cooling load requirements within the system using VFDs. Tertiary pumps circulate chilled water through the tertiary loop within each building. This loop is dedicated to specific loads or areas that have unique cooling requirements. You might find this system on the campus of your local university, which has a central plant and buildings distributed throughout the campus. These pumps are provided with VFDs to regulate the flow based on the specific needs of the tertiary loads within the building. Variable frequency drives, VFDs, all pumps, primary, secondary, and tertiary, are typically equipped with variable frequency drives, VFDs, to adjust pump speed and flow rates based on real-time demand. This flexibility ensures that the system operates efficiently under varying conditions. Energy efficiency. The primary, secondary, tertiary design allows for precise control over the distribution of chilled water to different types of loads with varying cooling requirements. By separating the loops, the system can adapt to changes in each loop without affecting the others, contributing to overall energy efficiency. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.